Welcome aboard, guys. Today I'm going to be tackling the day 7 of this Advent of Cyber 2024. So let's get right to it, right? Day 7. Oh no, I'm speaking in CloudTrail. As SOC mass approached, so did the need to provide those without with something to rate. Core for wares tried, they made it their mission. A gift for all wares, a SOC mass tradition. Although they had some, they still needed more. To pick up some books, they head to the store. The town's favorite books would no doubt make them jolly. They ticked off the list as they filled up the trolley. With the last book ticked off, the shopping was done. When asked for their card, the wearer handed them one. "I'm sorry," he said, as the clerk reclined. "I can't sell you this book, as your card has declined." The wearer put them back as they walked in confusion. How could this be? An attack? An intrusion? And when they logged on, the wearer got scared to find the donations, they just weren't there. Okay, this is the walkthrough video. So let's read the content, right? So monitoring in an AWS environment. Care4ware's infrastructure runs in the cloud, so they chose AWS as their cloud service provider. Instead of their workloads running on physical machines on premises, they run on virtualized instances in the cloud. These instances are in AWS, called EC2 instances, Amazon Elastic Compute Cloud. A few members of the Wareville SOC aren't used to log analysis on the cloud, and with the change of environment comes change of tools and services needed to perform their duties. Their duties this time are to help Care4wares figure out what has happened to the charity's funds. To do so, they will need to learn about an AWS service called CloudWatch. Okay, so CloudWatch is a monitoring and observability platform that gives us greater insights into our AWS environment by monitoring applications at multiple levels. CloudWatch provides functionalities such as the monitoring of system and application metrics and the configuration of alarms and those metrics for the purpose of today's investigation. Though we want to focus specifically on CloudWatch logs. Running an application in a cloud environment can mean leveraging lots of different services, e.g. a service running the application, a service running functions triggered by that application, a service running the application backend, etc. This translates to logs being generated from lots of different sources. CloudWatch logs make it easy for users to access, monitor, and store the logs from all these various sources. A CloudWatch agent must be installed on the appropriate instance for application and system metrics to be captured. A key feature of CloudWatch logs that will help the Wareville SOC squad and us make sense of what happened in their environment is the ability to query application logs using filter patterns. Here are some CloudWatch terms you should know before going further. Log events, log streams, and log groups. Log events. A log event is a single log entry recording an application event. This will be time-stamped and packaged with log messages and metadata. Log streams. Log streams are a collection of log events from a single source. And then log groups. Log groups are a collection of log streams. Log streams are collected into a log group when logically it makes sense. For example, if the same service is running across multiple hosts. Okay, CloudTrail. So CloudWatch can track infrastructure and application performance, but what if you wanted to monitor action in your AWS environment? This will be tracked using another service called AWS CloudTrail. Actions can be those taken by a user, a role granted to a user giving them certain permissions, or an AWS service and are recorded as events in AWS CloudTrail. Essentially, any action the user takes via the management console or AWS CLI or service will be captured and stored. Some features of CloudTrail include always on. CloudTrail is enabled by default for all users. The next one is JSON-formatted. All events types captured by CloudTrail will be in the CloudTrail JSON format. Then event history. When users access CloudTrail, they will see an option, event history. Event history is a record of the actions that have taken place in the last 90 days. These records are queryable and can be filtered on attributes such as resource type. Trails. The above mentioned event history can be thought of as the default trail, included out of the box. However, users can define custom trails to capture specific actions, which is useful if you have bespoke monitoring scenarios you want to capture and store beyond the 90-day event history retention period. Deliverables. As mentioned, CloudWatch can be used as a single access point for logs generated from various sources. CloudTrail is no different and has an optional feature enabling CloudTrail logs to be delivered to CloudWatch. Okay, so as mentioned, CloudTrail helps capture and record actions taken. Yeah, that's a fact. These actions could be interactions with any number of AWS services. For example, services like S3, Amazon Simple Storage Service used for object or storage, and IAM, AWS Identity and Access Management Service can be used to secure access to your AWS environment with the creation of identities and the assigning of access permissions to those identities. Will have actions taken within their service recorded. Okay, so not an IAM, right, will have actions taken within their service recorded. Okay, these recorded events can be very helpful when performing an investigation. Intro to JQ. What is JQ? Earlier, it was mentioned that CloudTrail logs were JSON formatted, right? When ingested in large volumes, this machine-readable format can be tricky to extract meaning from, especially in the context of log analysis. The need then arises for something to help us transform and filter that JSON data into meaningful data we can understand and use to gain security insights. That's exactly what JQ is and does. Similar to command line tools like set, AWK, and grep, JQ is a lightweight and flexible command line processor that can be used on JSON. So how can it be used? Now let's take a look at how to use JQ to transform and filter JSON data. The wheres being the wheres, they store their shopping list from the trip to the bookstore in JSON format. Let's take a look at that. So JSON format is book title, where Wally, genre, children, page count 20. Okay, and the same for many of these books. Right, JQ takes two inputs. Okay, so JQ takes two inputs. The filter you want to use, followed by the input file. We start our JQ filter with a dot, which just tells JQ we are accessing the current input. From here, we want to access the array of values stored in our JSON. With these parentheses, making our filter dot and then parentheses. For example, let's run the following command: JQ book list.json. Okay, the command above would result in this output. Book title, genre. Yeah, okay. It's better looking, right? Than this. Once we've accessed the array, we can grab elements from that array by going one step deeper. For example, we could run this JQ command. So it's the same with this pipe. So you're piping in book title and then book list JSON. Okay, so you're piping it by book title, right? If we want to view all the book titles contained within this JSON file, this would return a nicely formatted output like this. That's a lot nicer to look at, isn't it? Yeah, it gives you an idea of what JQ is, and what it does. Of course, JQ can filter and transform JSON data in many additional ways. In our upcoming investigation, we'll see the tool in action. So the peculiar case of care for where's dry fonts. Now that we have refreshed our knowledge of AWS CloudTrail and JQ alongside MaxKighty, let's investigate this peculiar case of care for where's dry fonts. The responsible where for the Care for Where's charity drive gave us the following info regarding this incident. We sent out a link on the 28th of November to everyone in our network that points to a flyer with the details of our charity. The details include the account number to receive donations. We received many donations the first day after sending out the link, but there were none from the second day on. I talked to multiple people who claimed to have donated a respectable sum. One showed his transaction. I noticed the account number was wrong. I checked the link and it was still the same. I opened the link and the digital flyer was the same except for the account number. MaxKighty recalls putting the digital flyer, Wareville bank account QR.png, in an Amazon AWS S3 bucket named Wareville Care for Where's. Let's assist MaxKighty and start by finding out more about that link. Before that, let's first review the information that we currently have to start the investigation. Okay, we have the day after the link was sent out, several donations were received. Yeah, since the second day after sending the link, no more donations have been received. They have probably gone to this other account, right? Someone has compromised this particular link or image stored in this S3 bucket, and they have been receiving the funds after the first day. That's my guess. So then the next one is a donator has shown proof of this transaction. It was made 3 days after he received the link. The account number in the transaction was not correct. MaxKighty put the digital flyer in the AWS S3 object name Wareville's bank. My bad. Just wanted to gain some time. Okay, yeah. MaxKighty put digital flyer in the AWS S3 object named Wareville's bank account QRPNG under the bucket Wareville Care for Where's. The link has not been altered, so it's probably been the image that was altered, right? I'm guessing. We'll find out. So, what else? Yeah, we were just waiting for this machine to boot up. Now we have enough information. Let's start the attached virtual machine in this task by clicking the Start Machine button below. Note that the machine may take 3 to 5 minutes to initialize. The machine will start in a split screen view. If the VM is not visible, use the blue Show Split View button at the top right of the page. Sure. Do I need to start the DevBox today? No. Do I need to start VM today? Yes. Is there a split screen available? Yes. Am I giving credentials? No credentials. Is there a link available? No link. Glitch did it. Let's examine the CloudTrail logs related to the where build care for where's S3 bucket for a quick example. A typical S3 log entry looks like this. Event version, user identity, type, principal ID, ARN, account ID. I guess this is a link. No, it's not a link. Account ID, this account access key ID, username. Okay. Okay, it might be overwhelming. Yes, it is a bit. I'm not gonna go through each and every one of these items. But okay, this is the client provided host. S3 app, Amazon. Okay, AWS, right? Okay, S3 bucket. Yeah, okay. It might be overwhelming to see the sheer amount of information in one event. There are some elements that we can focus on for our investigation. Okay, let me know that. So the field, user identity. Where's that? Okay, let's rate it. Details of the user account that acted on an object. Okay. Event time. When did the action occur? Event type. What type of event occurred? AWS API call or AWS console signing? AWS service event. Okay, the event source. From what service was the event logged? Event name. What specific action occurred? List objects, get bucket object. Okay, source IP address. From what IP did the action happen? User agent. What user agent was used to perform the action? Firefox, AWS CLI, request parameters. What parameters were involved in the action? Bucket name. Okay, by using the guide above, we can read the example log entry as follows. The IAM user wearable collector listed all list objects events of the S3 bucket name AOC CloudTrail wearable. The IP address from which this request originated is this particular IP. The user agent indicates that the request was made using the AWS SDK tool for Go. Okay. Now that we know where to look, let's use JQ to filter the log for events related to the wearable's bank account qr.png S3 object. The goal is to use the same elements to filter the log file using JQ and format the results into a table to make it more readable. According to MaxKidy, the logs are stored in the wearable logs, which is wearable logs. Where's that? Okay, let's access this. Don't show again. Access the terminal. Are you gonna open or what? LS. Wearable. Okay. What do we have here? CloudTrail logs JSON rds.log. Okay. So with the command above, we initially change our current directory to the directory MaxKidy mentioned via the cd command, change directory command, right? And we'll list the directory's contents using the ls command. Yeah, ls is to basically show all the content. Guys, this is just basic Linux stuff, right? We all should know that at this point. As you can see, two files are inside it, but we will focus first on the CloudTrail log.json for this investigation. Now, let's start investigating the CloudTrail logs by executing the command below. Okay, let's start investigating, right? So what's the command you want me to execute? JQ -R, then breakports, and then you're gonna pipe this by select event source equal s3.amazonaws.com close and dot request parameters dot bucket name equals where bill cared for where's, and now we close this, and then you have to add the particular file, right? Just gonna be CloudTrail log.json. Let's do a quick breakdown of the command we executed. Yeah, I do wanna, but let's first execute it, right? What could go wrong? Okay. JQ -R filter CloudTrail log JSON. So the -R flag tells JQ to output the results in raw format. Well, oh, okay. Oh, was this the full command? No, we executed this command. Okay, so the -R flag, which is this one, tells JQ to output the results in wait up. Okay, let's rate this. I was just wondering how would I go about activating the split screen view, but I guess I would have to scroll up. So let's understand this. JQ to output the results in raw format instead of JSON. Okay, so minus R flag tells JQ raw format. Okay, note that the filter section is enclosed with single quotes. Yeah, this is the filter section, right? All this is enclosed with single quotes. The last part of the command accepts the input file, which is CloudTrail log. Okay, so records. This instructs JQ to parse the events in the records container element. The records field is the top element in the JSON-formatted CloudTrail log. Top element. Okay. So then the pipe select use previous command's output and filters it on the event source and request parameters dot bucket name keys. Okay, yeah, event source, and then the other one is request parameters. Yeah, right. Bucket name. Okay, the values s3 Amazon AWS.com is used to filter events related to the Amazon AWS S3 service, and the value wherever careful wheres is used to filter events related to the target S3 bucket. Okay, as you can see in the command output, we were able to trim down the results since all the entries are from S3. However, it is still a bit overwhelming since all the fields are included in the output. Now let's refine the output by selecting the significant fields. Execute the following command below. Refine the output by selecting the significant fields. Okay, so we are just executing this command again, this time with also raw format, but what are you doing different now? Event source, also event source, and request parameters bucket name, and you're piping it by event time, event name, user identity, dot username. What does this do? NA, request parameters bucket name, NA, request parameters key. As you can see, we have appended another pipe. Yeah, that's what I was just wondering. After a previous filter, yes, you have. Let's discuss it quickly, okay? So what does this do? Event time, event name, user identity, and then this. Okay. The pipe filter uses the previous command's output and formats it to only include the defined keys such as event time, event name, and user identity.username. The defined keys are enclosed with square brackets. Yeah. Yeah, you see them enclosed with square brackets, right? To process and create an array with the specified fields from each record. Note that the string, yeah, that's what I just wonder, is included purely for formatting reasons. Okay, this means that if the defined key does not have a value, it will display NA instead. Okay, as you can see in the results, we could focus on the notable items. Okay, let's execute this first, right? Because I just wanna, then how do I go about showing split, show split here? Yeah. Okay, so now we're gonna execute this command. Don't tell me that I cannot execute it as I wish. Max Sky full test. Where are we? Too many commands. Okay, this is the first one. Then we executed. Now we're trying to execute this one. So what if I just copy full screen clipboard? Yeah. No, clipboard. No, let's go here. No, paste it. And then let's execute it. Okay, now we get a better looking file, right? With the attributes that we pipe them, right? With these commands. Okay, and did that show an A? If there's no value for that particular key, which is all right. As you can see in the results, we could focus on the notable items, but our initial goal is to render the output in a table to make it easy to digest. Let's upgrade our command with additional parameters. Okay. Also, let's first understand this, right? So minus R, event time, event name. And the new command preprints a column header row and is defined using square brackets since it is an array that corresponds to the selected fields. Okay, event time, yeah, sure. And note that a comma is used before the select filter to combine with those of the select filter result we previously had used. Then there's a pipe at TSV, sets each array element the output processed after the filters is as a line of tab separated values. Then column minus T minus S, it takes the output of the JQ command, now resulting in tab separated values, and beautifies its results by processing all tabs and aligning the columns. Okay. In tab separated values, beautifies its results by processing all tabs and aligning the columns. Okay. Let's see how it looks. Okay, so yeah, it does look like a bit of a table, right? Event time, event name, username. So yeah, event time, event name, bucket, key, source. Where's the source? Oh yeah, here it is. Source IP, right? Okay. And then filters of the records, and you pipe them by event source. Equals a string and request parameters bucket name, and you pipe them by these parameters: event time, event name, user name, event. Oh yeah, user identity username, which is this particular column, and then the bucket name, request parameters bucket name, and then request parameters key, and then the last one is source IP address, right? Source IP. Yeah, okay, and then TSV, what did this do? Sets each array element, the output process after the filters is a line of tab separated values. Oh, I get it. Tab separated values, TSV. Okay, makes sense. Then you specify the file, right? And where's this? Where is this column minus T minus S T? Oh, it's at the end. What does it do? It takes the output of the JQ command now resulting in tab separated values and beautifies its result by processing all tabs and aligning the columns. Okay, so it's just a beautiful a beautifier command, let's say. Okay, now our crafter command lets us summarize S3 activity from a CloudTrail log. Yeah. Um, Now that we have crafted the JQ query that provides a well-refined output, let's look at the results and observe the events based on the columns. This might come in handy actually. These commands that I'm just looking at. Just gonna close this. Then um mm, mm, mm. So maybe AWS. And then you note and then because um uh um what would I name this? Checking logs in AWS environment. And then you have the JQ command. JQ parse command that allows you to filter by purpose, whatever. No, any JSON file, right? And then we're gonna just go ahead and copy and paste some commands, just because I want to take note of this. For instance, this command. Oh, that's not the command I was looking for, boy. Yeah, that's much better. Okay, so then I also wanted to like yeah, let's just hit split screen view. Maybe just viewing full screen, so I can have this open in another tab or browse, and then I can just take note of all these commands. Because they may come in handy whenever I'm just checking any logs in a particular log environment. I personally do use S3 buckets. So I guess for my personal web applications and clients projects. So just allow me a second, guys. It's important to take note as you learn, right? So what I'm gonna do is, I do like the explanation here, so I'm just gonna screenshot this particular table and then paste it right below the command. And then I'm gonna paste another command, which is this one, JQ. Okay, beautiful. Now, I also want to understand it, so I'll probably just keep this as reference because I'm not gonna be going through the TryHackMe room again, right? So I want to extract as much information as I can just to have it easily accessible. Just so you guys know, I use Obsidian to take notes, right? That's just the tool I like, and I like that you can use markup, yeah, markup language, and you can basically structure whatever you want and easily take note of things. So that's my preference, right? I understand some guys prefer Notion or just Obsidian. That's the job for me, so I stick to that, right? If it works, don't touch it. So the next one is this particular. You may observe we have added the following items to our command. Yeah, this is the thing that we were just reading through and we understood. So let's just copy. Okay. Okay, what's the next one? Max Sky full dash. Sending information of which tool OS. Okay. What about here? Just similar to the previous one, right? So then this one is probably one that I want to take note. I will read through it in a bit. I just wanted to just first take note of the commands and then read through them to understand them, right? Yeah, so I don't have to do this for each and every one of them. Bear with me a second, guys. What else? This one, there's no explanation, just the commands I guess we've previously learned. So yeah, that's it. Let's keep going. Where were we? Yeah, I already read through this. We understood this particular thingy. Our crafted command lets us summarize history activities from our CloudTrail log. Now we have crafted.jq query that provides a well-refined output. Let's look at the results and observe the events. Based on the columns, we can answer the following questions to build our assumptions. How many log entries are related to the where care for where's bucket? Okay. Which user initiated most of these log entries? Okay. Which actions did the user perform based on the event name field? Were there any specific files edited? What is the timestamp of the log entries? What is the source IP related to these log entries? So looking at the results, 5 logged events seem related to the whereabouts care for where's bucket, and almost all are related to the user glitch. Aside from listing the objects inside the bucket, is that so? Yeah, username glitch. So aside from what? Aside from listing the objects inside the bucket list object event, the most notable detail is that the user glitch uploaded the file variable bank account qr.png. Did he? Oh yeah. Put object. Yeah. He uploaded the file on November 28th. Is that so? Yeah, that's all. Okay, this seems to coincide with the information we received about no donations being made 2 days after the link was sent out, right? So MaxKite is sure there was no user glitch in the system before. There's no one in the city hall with that name either. The only person that MaxKite knows what with that name is the hacker who keeps to himself. MaxKite suggests that we look into this anomalous user. MaxKite fooled us? MaxKite wants to know what this anomalous user account has been used for, when it was created, and who created it. Enter the command below to see all the events related to the anomalous user. We can focus our analysis on the following questions. Okay. So what are you filtering here? You're creating the columns, event time, event source, event name, username, source IP, and then you're also iterating through this, and then you're piping them through, select user identity, username, glitch. Oh, okay. Event time, event source, event name, user identity. Okay, and then if there's no field, yeah, then TSV, tab, what was it? Tab S value. What would the S stand for? I have it here in my notes. Takes the output UQ command or resulting tab separated values. Okay, this is just a bit to verify this particular looking table. The results show that the user glitch mostly targeted the string. Okay, no, I haven't executed the command. Come on, give me a second, guys. Oh yeah, oh, am I able to copy and paste it? Username. Oh no, it's not the command that I was looking for, right? There's no glitch. No, no, no. No. I probably have to also copy this. But wait, there's no. Oh, here. Here it is. The clipboard. event name glitch. Yeah, this is the one. Okay, you can go now. Now I should be able to paste it, right? User glitch. Yeah, so what do we get after this? So the results show that the user glitch mostly targeted the S3 bucket, right? S3 Amazon, yeah, S3. Good. Okay. The notable event is the console logging entry. Where's that? Console logging entry. Okay, signing Amazon glitch with this particular IP. Okay, on the 28th. Okay. Which tells us that the account was used to access the AWS management console using a browser. We still need information on which tool and OS were used in the request. Let's view the user agent value related to these events using the following command. Okay. Okay. I just want to take note of these commands as well. So I thought they were not going to be relevant, but I think they might come in handy at some point, just to have something to just alter easily, right? And get a particular thing for a particular user and stuff. So then this one. Okay, we're done. We still need information which tool and OS were used in this request. Let's view the user agent value related to this. This command is the use case, right? Okay. And then did we execute this? No. Let's first understand the two user agent. Where's that? So just the columns, record, select user identity, username, event time, event name, user identity, username, source IP address, user agent, and then what? There are two user. Okay, let's execute this and see what up. Let's copy it to the clipboard. Okay. Clear. Okay. How's this different from this? CloudTrail column, user agent. Oh yeah, I see you. User agent is added, right? And then the user agent is this long thingy. So what are we looking at here? We still need information about which tool and OS were used in the request, right? Because as per what we have seen, he has logged in using a web browser to the console, right, from the Amazon. The user glitch mostly targeted the normal console and tells us that the account was used to access the AWS management console using a browser. Yeah. So there are two user agent values included in all log entries related to the glitch user. Glitch, two different user agent values, right? Mozilla, and then Macintosh. Yeah, so the Macintosh Intel. And then what is the other one? S3 console, I guess. No, yes. S3 console, right? And then this gets storage loss configuration. Okay, let's keep reading. S3 console, yeah. AWS, this particular user agent is what? Linux, so what does it tell us? S3 console, AWS internal, AWS SDK, Java, Amazon, okay, vendor, Oracle Corporation. This is the user agent string for the internal console used in AWS. It doesn't provide much information. Yeah, I can see that. But this one does, right? So this user agent string provides us with two pieces of interesting information. The animals account uses a Google Chrome browser within a Mac OS system. An experienced attacker can forge these values, but we should not dismiss this information. It can be valuable when comparing different log entries for the same user. We'll park the current information for now. Let's gather more information to connect the dots. So the next interesting event to look for is who created this anomalous user account. Okay, we'll filter for all IAM related events, and this can be done by using the select filter event source equal IAM.amazonaws.com. Let's execute the command below and try to answer the following questions. What event names are included in the log entries? What user executed these events? And what is the user's IP? Let's copy. Let's execute the command. Copy. Let's go to the clipboard. Let's put this here. Let's execute the command. So what was the question? What event names are included in the log entries? Place policies. Create user. Okay. What user executed these events? Max ID. What is the user's IP? We got the IP. Okay. So what now? Based on the results, there are many list policies events, right? Yes, there are. By ignoring these events, it seems that the most significant IAM activity is about the user max ID, invoking the create user action, and consequently invoking the attach user policy action, right? Create user and attach user policy. Okay. The source IP where the requests were made is 53.94.201.69. The source IP where the requests were made. Yeah. Remember that it is the same IP. The anomalous user glitch used. Let's have a more detailed look at the event related to the create user action by executing the command below. Okay. Let's go. I'm going to take a look at the event related to the create user action by executing this particular command. Okay. Create user. Yeah. Macintosh into macOS. Management. Okay. Based on the request parameters of the output, it can be seen that it was the user Max Kaidi who created the anomalous account. Yeah. Username. Yeah. Max Kaidi. Now we need to know what permissions the anomalous user has, right? It could be devastating he has access to our whole environment. We need to filter out the attached user policy event to uncover the permissions set for the newly created user. This event applies access policies to users. To find the extent of access to the account, let's filter for the specific event by executing the command below. Now we need to know what permissions the anomalous user has, right? User agent, permissions, max ID, creation date, access key, username, event time, attach user policy, username glitch, policy, administrator access? That's no bueno. Okay. So he's basically provided him with administrator access. Okay. Maxkai is baffled by these results. She knows that she did not create the anomalous user and did not have the privileged access. She also doesn't recognize the IP address involved in the events and does not use Mac OS. She only uses a Windows machine. All this information is different to the typical IP address, a machine used by Maxkai, so she wants to prove her innocence and asks to continue the investigation. Logs don't lie. Okay, I like that. Maxkai suggests looking closely at the IP address and operating system related to all these anomalous events. Let's use the following command below to continue with the investigation. Let's do it. Major malware. What I'm hearing. Okay, so what are you doing here? You're the column, select source IP address. Okay, you're filtering by IP address. Okay. Then you want to retrieve the information, event type, event name, user identity, the username, source IP address, CSV. This is just to verify this. Okay. Based on the command output, 3 user accounts. Maxkai, glitch, and major malware were accessed from the same IP address. The next step is to check each user and see if they always work from that IP. Let's focus on each user to see if they always work from that IP. Enter the command below and replace the placeholder with the username. Right? And we have 3 usernames. So let's do that. Copy. Paste. Now, where's the placeholder? Oh, here. placeholder, come here. Max Kairi. Max Kairi. Only one D. My bad. What did I do? Okay, we got it. What now? Console login. So we're just trying to find out which IP addresses they normally use, right? 3 users' accounts, right, were accessed from the same IP address. The next step is to check each user and see if they always work from that IP. And we can see for Max Guide, he does use different IP normally, right? Not, let's say, on the 25th, right? He was using a different IP, 26th, and then he changed to, on which date? On the 28th. On the 28th, he started using that IP address, 5394, right? Which is weird. Let's do the same for next one is glitch. What with glitch? He does. Where's the IP address? Oh, I think I did something fishy. Max Guide instead of Max Guide. Glitch. Yeah. I don't see no IP address. Oh, here it is. Next step is to check each user and see if they always work from that IP. Okay, see you. Using the commands below and replace placeholder with username. Yeah, okay, I've already replaced that, and now the next one I have to check is mayor malware, right? But I don't see any IP address here. Oh yeah, here it is. So then it uses AWS internal. What's that mean? He always uses this particular one, the glitch. He never uses a different IP address. So what about mayor malware, right? Mayor malware. Also same thing. So what's up? Access from the same IP, and the next step is to check each user and see if they always work from that IP. Let's focus on each user and see if they always work from that IP, and recommend below and replace the placeholder with the username. While gathering the information for each user, we can focus on our investigation on the following questions. Which IP does each user typically use to log into AWS? Which OS and browser does each user usually use? Mozilla, Macintosh, Intel Mac OS. Okay. Then what else? Are there any similarities or explicit differences between the IP addresses and operating systems used? I'm looking out for that. So Max Guide uses Macintosh, Mac OS 10.15.7. Same as this guy. When they're using that particular IP, right? But we did note that Max Guide did use different source IP, at least for this, and then he used a Windows machine, right? in regards to the other guys, like glitch. He always uses that same IP, and then he also always uses that same uh, browser and OS to access. And then for major malware, what? Why did I execute it twice for glitch? All right, major malware. Major malware does also use the Macintosh Mac OS. But yeah, he always does use that console logging. Okay. So based on the result, we have proven that McSkydy used a different IP address before the initial authentication was discovered. Yeah, that's the fact. Moreover, all evidence seems to point towards another user after correlating the IP addresses and user agent used by each user. Who do you think it could be? McSkydy has processed all the investigation results and summarized them below. This scene starts with anomalous logging with the user account McSkydy from IP, this particular IP, right? Shortly after the login, an anomalous user account glitch was created. Yeah. Then the glitch user account was assigned administrator permissions, right? Then the glitch user account then accessed the S3 bucket named Whereabouts Care for Wares and replaced the Whereabouts bank account QRPNG file with a new one. The IP address and user agent used to log into the glitch, McSkydy, and major malware accounts were the same. Yeah, the user agent string and source IP of recurrent logins by the user account McSkydy are different. Yeah, so definite evidence. McSkydy suggests gathering a stronger proof that the person was behind this incident. That person was behind this incident. Luckily, Warville Bank cooperated with us and provided their database logs from their Amazon relational database service. They also mentioned that these are captured through their CloudWatch, which differs from the CloudTrail logs as they're not stored in JSON format. For now, let's look at the bank transactions stored in the Warville's RDS log file. Since the log entries are different from the logs we previously investigated, McSkydy provides some guidance on how to analyze them. According to her, we can use the following command to show all the bank transactions. grep is a Unix command line utility used for searching strings within a file or an input stream. So that's what we're going to be using, I guess. grep insert rds.log. Into variable bank transaction account number, values, major malware. From the command above, McSkydy explained that only insert queries from the RDS log pertain to who received the donations made by townspeople. And it was major malware. What date? 28th. Yeah, so he was the one receiving them. Given this, we can see in the output with the two recipients to all donations made within 28th November, which is major malware, and then care for where's phone. Where is that? Yeah, care for where phones received them upon also on the 28th. So as shown above, the careful words found received all donations until it changed into a different account at a specific time. The logs also revealed who received the donation afterwards. Given the account owner's name, with all these findings, McSkydy confirmed the assumptions that made during the investigation of the S3 bucket, since the sudden change in bank details was reflected in the database logs. The timeline of events collected by McSkydy explains the connection of actions conducted by the culprit. So timestamps 2000 CloudWatch RDS logs, last donation received by the Care for Word funds, and then CloudTrail logs, CloudTrail bank details update on S3 bucket, and then just a minute after that, or some seconds after it, CloudWatch RDS logs, first donation received by major malware. So what is the other activity made by the user glitch aside from list object action? You're talking about what is the other activity made by user glitch? Glitch, what did you do? Glitch. Event time. AWS internal get stored. Oh no, what did I do? No. Will I still have access to all the commands? Yeah. Okay, what is the other activity made by the user glitch aside from list object action? Well, put object. That's the thing that basically replaced the image that we had there. So yeah, what is the source IP related to the S3 backend activities of the user village? This particular one, right? 53.94.201.69. Yeah, based on the event source field, what AWS service generates a console logging event? Event source field. It's signing.amazon.aws.com. When did the anomalous user trigger the console logging event? Console logging. He triggered it on what format are you looking for? First of all, oh, the whole thingy. Okay, I'm gonna have problems with this. Just give me a second. The console login, right? User the console logging event. So it's this particular thingy here, and we have this. Can I copy? Right click. Copy. Right click. Paste. It worked. It worked. What was the name of the user that was created by the MaxKidy user? It was Glitch. What type of access was assigned to the anomalous user? Administrator access. What do you mean? But where do we find this? We found it, right? Like, sign in, create login profile. Here comes the login. Attach user policy. I think records events. Attach user policy. Yeah. So what? Attach user policy. Request parameters policy. Glitch management. Administrator access. That's it. Which IP does Mayor malware typically use to log into AWS? Mayor malware typically use. I think it's the same ones here. It was, right? Yeah. What is MaxKidy's actual IP address? MaxKidy. Oh yeah, he did have a different IP address, right? Which was, where was it? Here, 31 to 20 to, let's copy this. Right click, copy, paste. What is the bank's account number owned by Mayor malware? Should be in the last record. Account number by Mayor malware. It's this one. Copy. Then paste. Yeah. Want to learn more about log analysis and how to interpret logs from different sources? Check out the log universe room. Okay, that sounds like fun. I mean, not really. Being sarcastic. But yeah, it's still good to know, right? Because you can basically understand what somebody has done, just for you to just. I understand how it's relevant for the SOC team, right? To track down the bad actor steps. So that's it, guys. We finished the, which day was day 7, right? So yeah, that's it, guys. Thanks for sticking up with me. It was fun. We took note of some important commands that might come in handy in the future. That's that. I think I'm gonna head out to the gym right now. So yeah, keep learning, guys. Train hard, and I'll see you around next time. Thanks. Peace.